Okay, this lecture is over Chapter 10 from the Cisco curriculum. It is entitled OSPF Tuning and Troubleshooting. So first thing we'll do is talk about the introduction and talk about tuning and troubleshooting. That's what this chapter is about. Some of the reasons we might want to do that is we may want to manipulate the designated router and or backup designated router election process to control what ends up being the designated router and the backup designated router. We may want to propagate default routes through the OSPF protocol. We may want to fine-tune the interfaces on the routers, and we may want to enable authentication for security. So, like most chapters, 10.0.1.2 starts out with a class activity. This is on the designated router and backup designated router election process. I'm not going to assign this activity, but you should click on the class activity PDF down there at the bottom and at least read through it. Okay, 10.1.1.1 is talking about different OSPF network types. As we click through the figures, they're going to show different types. So here we have point-to-point over a serial connection, and we can run OSPF over that connection. The second one is a multi-access network where we have multiple routers and switches. The third is a non-broadcast multi-access network. So we have multi-access, but broadcast are not being sent because frame relay does not propagate or transmit broadcast. The fourth is a point-to-multipoint network, again using frame relay to set that up. And then the fifth that is here is what's called a virtual link network. Basically, a virtual link network is a special OSPF network that's used to interconnect distant OSPF areas to the backbone area. And again, the backbone area is area 0. The problem we have with multi-access networks, especially as we increase the number of routers, is that we end up with many adjacencies. And the more adjacencies we have, the more link state advertisements that are sent, possibly eating up a lot of bandwidth in our network. So in this first figure here, R1 is the designated router. So we now just have 3 adjacencies, which is not going to really, using this formula, give us a lot of link state advertisements. So now if we go back and interconnect these, we have 6 neighbor adjacencies, which is going to increase the number of link state advertisements. So here we have a formula that shows us as we increase the number of routers, geometrically the number of adjacencies go up. So the important thing out of all this section is more routers implies many more adjacencies. So here, router 1 is the designated router. The purpose of the designated router is to cut down on those link state advertisements. So in this topology, instead of having 6 adjacencies like we saw in the previous set of slides, we only have 3 because only the designated router is going to send out link state advertisements. This is going to show us the role of the designated router. So I'm going to play this animation Adjacencies are formed with the designated router and backup designated router only. So the link state advertisements went there. And then the designated router is going to send out any link state advertisements that are needed to all the other routers. So that was a lot less advertisements than we would have had if we were not using a designated router. So here we have a topology that we're going to use in this section. R3 is the designated router because it has the highest router ID, the 3333. Router 2 is the backup designated router because it has the second highest router ID. And over here we have router 1, which is not a designated router or a backup designated router. So it'll be labeled as DR other is how we would refer to that. In 2, 3, and 4, we're going to talk through router 1, router 2, and router 3. So in figure 2, we have router 1. We show IP OSPF interface, and we do the gig 00. Notice that it says its state or role is DR other. It shows that the designated router is 3333, gives its IP address, and tells us what the backup designated router is, that it's 2222 for the router ID. And then here's the IP address that we would talk to that backup designated router. And then down here, labeled with a 3, is it's showing our neighbor count is 2, and it's showing our adjacencies. And again, mentioning the role of those adjacencies. Figure 3 does the same thing for router 2. Notice that it is a backup designated router with priority 1. We haven't talked about the priority yet, but we will later in this chapter. And then down here we have the adjacency count. And I think I skipped over it, but here's the DR and the BDR information like we saw before. And then if we look at router 3, kind of the same thing. It is a designated router with priority 1. It's showing the designated router and the backup designated router information, both the router ID and IP address. And then down here, it's showing the neighbor adjacency that we have with other routers. This section is entitled Verifying Designated Router and Backup Designated Router Adjacencies. So in figure 1, we're on router 1. We say show us our neighbors. It's going to show us our neighbors. It's going to give us the router IDs and tell us what interface. And here it's going to tell us which one's the backup designated router and which one's the designated router. So that was router 1. Same thing on router 2. It's showing that it has the designated router as a neighbor. And at 1111, we have a DR other, designated router other, and tells us IP address and what interface we're talking to. And then same thing for router 3. The only thing that changed was here, instead of having 333, since we're on 333, it's going to show us 2222 and say that it's the backup designated router. We've talked about the election process and setting up the designated router and backup designated router. The process is over here in the text. The router ID can be set or determined in one of 3 ways. We can actually manually configure a router ID, which we've done in previous chapters. If there is no router ID configured, then the router ID is determined by the highest loopback IP version 4 address. And if the router has no loopback interface, the router ID is determined by the highest active IP version 4 IP address that is being used on that router. talking about how the election process might work is we have a topology here. In this case, router 3 down here fails. R2, which was the backup designated router, becomes the designated router. So the one thing they're not showing here is this was the designated router prior to its failure. And then over here, 1111 was the DR other, and it is going to become the backup designated router as shown here. Now then, what happens, and this may not work exactly the way you think it might, is that router 3, which was originally the designated router, comes back online. When it comes online, it will become DR other. It will not have an election process or change any of the settings, in this case of router 1 and router 2. Even if we add a new router, which we're showing here, so we added one that had the highest router ID, 4444, but it's not going to call for an election process in this case, and it's just going to declare that it is DR other. Continuing on with this, if router 2 fails, router 1, which was a backup designated router, is going to become the designated router, and then an election process occurs for the backup designated router. The remaining router with the highest router ID is router 4, so it will become, it'll switch state from DR other to being the backup designated router. We have seen how we can go in and change the router ID and manipulate what router is going to become the designated router and or the backup designated router. But there's actually a better way to do that, and that's by changing the interface priorities. And over here in the text, we have a way to do that: IPOSPF priority and some value. And right below that, over in the text, it talks about the acceptable values. If you set the priority value to 0, that means never become the designated router or a backup designated router. And if you set it between 1 and 255, that is going to make it more likely that the router with the highest priority is going to become the DR or the backup DR, whichever one we are trying to figure out because of a topology change. 10119 is going to show you some things related to changing that priority. So we're back to the 3 router topology that we had before. In figure 2, we're going to log into router 1 and set its OSPF priority to 255. So that's going to be the highest value possible. And we did that on interface G0/0. Now we go to router 3 and set the priority to 0 on its gig 0/0, which basically means router 3 will not become a designated router or a backup designated router. Now if we go to router 1 and basically say reset the OSPF process, which means there's going to be an election, what happens is it marks it down and its neighbors are down because OSPF stops running. But then if we go back and say show me interface gig 00, it's going to go through and say, hey, I'm the designated router. My router ID is 1111, and then I have 2 neighbors. And then down here, if I say show me the neighbors, it's going to show me those neighbors along with the fact that 2222 is the backup designated router and 3333 is a DR other. And then it will give us those IP addresses. And then finally, figure 6 is a go back and do some of those commands on your own to make sure you can replicate those. 10.1.1.10 is an activity on identifying the network types. There's actually three different figures, three different activities kind of in one. So you can go through and do those on your own once you think you're ready. This is an activity. It's kind of a more guided activity instead of just saying, hey, there's three figures, there's three different activities. So basically what you do is you go through and you look at the information provided and then think about the election process and then determine what router in this figure is going to end up being the designated router. So you can do that on your own. 10.1.1.12 is a packet tracer activity. I'm not necessarily going to assign all the packet tracers and labs in this chapter, but I do want to assign this one, so watch for this packet tracer activity to show up in Blackboard. 10.1.1.13 is a lab. Normally labs would be done on physical equipment or on the NetLab. I'm probably not going to assign this lab, but you should click here on the PDF and at least read and understand what the lab was trying to accomplish. 10.1.2.1 is talking about propagating a default static route. So here we have a topology that we've seen a number of times. The default route would be out to the internet, so it would be this 209.165.200.224 address. So if we go into router 2 and we say configure the default route to be that address, and then we go into the OSPF process ID 10 and we say default information originate, that's going to do two things. It's going to first propagate that 209 address as being the default route, and it's going to tag it as originating from R2 so that we know where that route came from. 10.1.2.2 is verifying that we do have the route set. So if we log into router 2 and look for the gateway, since in iOS most of the time instead of default router it's going to call it the gateway of last resort, it's going to tell us that it is the default route to 000. Also the gateway of last resort tells us that, and it gives us that 209 address to show that the default route is over the internet. Figure 2 of this section is, can you go through and replicate the command or commands that we did in the previous figure. So you can do that whenever you're ready. .10.1.2.3 is the exact same thing, except it's for OSPF version 3, which means we're dealing with IP version 6. So here's the same topology addressed with IP version 6 addresses. Instead of show IP route, we of course use show IP version 6 route, and this shows us the routing table. And then if we go to router 2, we do the same thing we did before, is we define the default route. Again, ::/0 is the all 0 addresses, which means default route. And then it's going to tell it to distribute that information and mark it as originating from router 2, exactly like we had before with IP version 4. 10.1.2.4 is verifying the propagated IP version 6 default route. So if we show the route table for router 2, here's the default route, tells us how we get there. And then this is a do-it-yourself activity once you're ready to make sure that you can replicate that process or commands. 10125 is a packet tracer activity on propagating a default route in OSPF version 2. I will assign this packet tracer most likely, so watch for it to appear in Blackboard. 10131 is talking about hello timers and dead intervals. So we get that information by listing an OSPF interface, in this case serial 000. It's highlighted what's of interest here, so it's telling us the timer intervals that are configured is the hello timer, which is 10. Again, the hello timer is how we make sure adjacencies are still valid, and the hello interval is the time between hello packets. So that's how often this router will send packets. That's in seconds. The dead interval is the time after which, in this case, 40 seconds goes by, and we have not received a hello packet from a router, from one of our neighbor routers. We're going to declare that neighbor to be down. So here we're on router 1. We're telling us to show us the information. So we have 3 different interfaces. They're all set to hello timer 10 and a dead of 40, which I believe is the default. And then finally here, the show IP OSPF neighbor. We've discussed this several times, I believe, but we didn't actually talk about the dead timer. So this router had its dead timer default to 40. So this 35 and this 33 are basically a countdown from 40. So if we receive a hello packet, that'll go back up to 40. If that ever goes down to 0, then whatever neighbor went to 0, we would mark it as being down. We can modify these if we want to. So here we've gone in and set the hello timer to 5 and the dead timer to 20. And it's going to go through and tell us that. And in this case, 222's timer expired. So it's going to mark 2222 as down. In the next figure, we look at the IP OSPF neighbor and notice that indeed 2222 has been removed from the neighbor list. 3, we're going back and changing it, and in this case it's just going to reload it with the new value. And then here we're looking at the timers to see that it's 5 and 20. And then when we look at the neighbors, we see the neighbors and see the countdown timers for the dead time for those. Here we can do the same thing with IP version 6 or specifically OSPF version 3. This is the same topology with IP version 6 addressing. Here we went in and we lowered the interval timers. We can see that caused router ID 2222 to go offline just like before. When we show the neighbors to router 1, we don't have any neighbors. If we go to router 2 and change the hello interval to 5, it's going to bring up 1111 on serial 000 as being up. And then if we do the OSPF neighbor, if we list those out, we'll see that yes, we have two neighbor routers, which is what we should have. 10134 is a packet tracer on going through and modifying some of the OSPF version 2 configuration parameters and verifying connectivity once we've done that. I'm probably not going to assign this. If I do, of course, it'll show up in Blackboard, but at this point, just read through the PDF. 10135 is the exact same thing, but a lab. I'm definitely not going to assign this. Switching to section 10.2, we're starting out talking about components of troubleshooting single area OSPF. So one of the problems is forming OSPF adjacencies. And if those don't form, here are some of the problems. The interfaces where we think an adjacency should be formed are not on the same network. Maybe you have wrong subnet mask or something like that, or just fat-fingered IP address. The OSPF network types do not match. The hello and dead timers do not match. We've maybe accidentally configured an interface to be passive. And if you recall from previous chapters, passive means it will not pass link state advertisements and will not form adjacencies. Maybe we forgot or mistyped one of our network commands telling what networks are connected to our router. We may not be using the same authentication type or the correct password on authentication. And for this to work, the interfaces must be configured correctly, and they must both be in the up state, which means they are fully functioning. So these are some of the problems that we could have that would cause adjacencies not to be formed. We saw this either in Chapter 8 or Chapter 9, talking about transitioning through the OSPF states. So what happens is when an interface comes online, it will initially be in the down state. It means it hasn't received any hello packets, and it will send a hello packet and then start transitioning to the init state. Hopefully at this point, hello packets are received from the neighbor. They will have the neighbor's router ID, and it will start transitioning, since we saw hello packets both ways, to what's called the two-way state. We will go through an election process to elect a designated router and a backup designated router. We will then start synchronizing our databases, so we'll switch to X start state. It negotiates a master-slave relationship and exchanges database packets. They exchange those packets and load them, start loading them into their database. When we do that, link state request and link state updates are used to gain additional route information. We then transition to the full state, which means the routers have converged. And again, routers converging mean that they have the same or consistent and correct routing tables. This section is entitled OSPF Troubleshooting Commands. So there's going to be 5 sets of commands or 5 figures that we're going to look at. So if we go in and say show IP protocols and we're using OSPF, this allows us to verify vital OSPF configuration information. Do we have a routing table? What networks are we routing for? What is our router ID? What's our OSPF process ID? And what area, in this case, these addresses are being listed as an area 0, which, if you recall, is our backbone area. Figure 2 is showing us how to verify adjacencies. So we're saying show IP OSPF neighbors, and this should be all the routers that are adjacent to us, so you can verify and make sure that all the routers that you expect to be there are actually there. Figure 3 is verifying interface parameters. In this case, we're looking at serial 000. It is up. It's in area 0. Its router ID is 111. Its process ID is 10. Tells us our hello timer. Tells us our neighbor count. Shows us what neighbors it knows about. And some other information that we haven't talked about yet. Figure 4 is examining the process ID and the router IDs. So show IP OSPF right at the top shows the process ID and the router ID, and then gives us a bunch of other information. And the last figure is going to show us learned routes. So we can go through and see all the routers and which links they apply to. .10214 is basically showing us a flow chart. You know, we start out, if we have connectivity issues, we first look to see if it has something to do with routing. We make sure our neighbor table is correct. If it's not, we troubleshoot it like we talked about. If it is correct, then we look at our routing table and see if it's correct. If it's not, troubleshoot that like we just showed. If it is correct, then we use ping to see if the traffic makes it to the desired path. If it does not, then we troubleshoot it. If we make it all the way through here, we will hopefully have, if we did not find any problems, a functioning network. 10215 is an activity going through and making sure that you know which command to use for the particular issue you're trying to troubleshoot. So there's 5 of those that match up with the 5 things we just talked about a couple of sections ago. So when you think you're ready, you can go through and do that activity on your own. 10221 is talking about troubleshooting neighbor issues. So here, for the backbone area, area 0, we have topology that we've been seeing many times. All these figures are going to apply to router 1, which is the router down here at the bottom left. So the first thing we have is, how do we look at the routing table and making sure the information is correct. The next thing we do is we check the interfaces to make sure that they are correct and configured the way we expect and that they're up. We can then test connectivity by using the ping command. In this case, the connectivity is working fine. In figure 4, we want to verify that OSPF is up and running. So we can see that there is an area 0 mentioned, which is an OSPF thing, so we're in the backbone. On 5, we're verifying that any interfaces that should be marked as passive are indeed included in the list of passive interfaces. Here we went in and we said no passive. So basically what happens is serial 000 was passive before, and for some reason we no longer want it to be passive, so we use the no passive command to correct that. And then finally here we verify the route to make sure the route table is what we would expect it to be. Uh, 10222 is talking about troubleshooting router table issues. Again, same topology we've been looking at. Here we look at the routing table for router 1, and we go through and would verify that all this information down here is what we would expect it to be to match up with this topology. In figure 3, we're showing IP protocols. So it's going to show us that we're running OSPF, process ID 10, router ID 3333, and then it's going to show us our routing table with an IP address and a wildcard subnet mask that we talked about either in Chapter 8 or Chapter 9. Here we can go through and say, show me all the things related to the OSPF section in the running config. So it would be the router ID, how is the passive interface configured, and what network are we servicing. So that's just another way to get the OSPF information from the router. Here we're on router 3, and we're going in and advertising that for OSPF process ID 10, we do have a network here, again with a wildcard subnet mask that's in area 0. And then it's just telling us that that configuration was changed. And then here we're saying show IP route OSPF, and we're verifying the routing table is what we would expect it to be. 10223 is a packet tracer entitled Troubleshooting Single Area OSPF version 2. I probably will not assign this, but like I've been telling you, you should read through the PDF just to see what that was trying to accomplish. Okay, 10231, we're kind of going to do the same thing for OSPF version 3. So here's our topology for the backbone area, labeled with IP version 6 information. We can show the protocols to verify the OSPF version 3 settings on the router. We can show the neighbors to verify our adjacency with the neighbors and make sure that's what we would expect it to be. 4, we're looking at the interface to verify things like router ID, process ID, that type of thing. On 5, we're going through and looking at the interface settings for the serial link 000 and make sure all those values are configured the way we would expect. And then finally, just like before, we would look at the routing table and make sure our routing table made sense. As far as troubleshooting OSPF version 3, again, we have the topology here, and we're verifying the routing table. We're making sure that we have interfaces that are configured correctly for our protocol, OSPF process ID 10. We show the running config. In this case, we're looking at the gig 0/0 interface to see if it is configured correctly. Notice they did not configure an IP version 4 address, but down here they did configure IP version 6, both its public IP and its link local IP. And here we're going in and actually saying on the gig 0/0 interface, we want to run OSPF version 3 because it's IPv6 that we're talking about. And then finally here we would go through and verify the OSPF version 3 routing table, in this case for router 1, to make sure it made sense. 10233 is a lab troubleshooting basic single area OSPF version 2 and version 3. I will not be assigning that, but you should read it. 10234 is a lab called Troubleshooting Advanced Single Area OSPF version 2. I will not be assigning that. Uh, 10241 is talking about multi-area OSPF. So also showing you here is that we have a backbone area. Again, typically no user devices are in our backbone area. And then if we click the 2, then it's showing us non-backbone or regular or normal OSPF areas. Next, we're going to talk about the data structures related to OSPF. We've talked about that before. We have routers running OSPF. They exchange either IP version 4 and or IP version 6 network traffic, or OSPF protocols, version 2 of course being version 4 of IP, and version 3 of OSPF being IP version 6 based. But in all cases, we have an interface table for the interfaces on the router. We have a neighbor table for adjacency. We have a link state database that tells us the status of our links. And then we have a routing table that contains our routes. So those are both the same. Again, the only difference is, are we recording and using IP version 4 addresses, or are we recording and using IP version 6 addresses? .10243 is another packet tracer entitled Troubleshooting Multi-Area OSPF version 2. I probably will not assign that, so read it. The next is another packet tracer. This time, instead of OSPF version 2, it's for version 3. You probably want to look over that, but I suspect it'll be almost identical to the packet tracer right before this. 10245 is a lab that is a combination of the 2 previous packet tracers. I will not be assigning this lab. This is a class activity called Mastering or OSPF Troubleshooting Mastery. I am not going to assign this, but you should read over it to see what they were trying to get at. 10312 is a skills integration challenge for probably the last 3 chapters. I'm leaning towards not assigning this. So you might want to read over it just to see what it was about. If I change my mind, of course, it'll appear in Blackboard. So this basically finishes up the entire curriculum for Cisco 3. They have something here kind of congratulating and talking about where you go from here. You can get information by clicking on these pluses. So there are certification exams. Again, you probably already know this. This course is Cisco 3. There are 4 Cisco classes that are offered at BCTC that are related to the CCNA, so Cisco Certified Network Associates certification. So you can go out and take those. It's a good certification to have. A lot of jobs, if they don't require certifications, will look very positive on certifications, especially some that are a little more difficult to get, like the CCNA. Down here they mentioned saving money on the cost of exams. You can visit this link. I'm not going to do it now because it'll take me out of the curriculum. But basically, I know 2 of the conditions are, first, that you have to be enrolled in a NetAcad class, which of course you are. We've been using it all semester. And then I think the other major criteria is on your first attempt of the final, you have to make a 75 or above. And if you do that, you get, I don't know it's exactly 50%, but I think it's pretty close to 50% discount when you go to buy a voucher to take the CCNA exam, if that's something you plan to do. Here they have something called Talent Bridge that's trying to connect students with Cisco certifications with, they say Cisco partners, but basically it's job hunters who are interested in people who have their Cisco certifications. And then the last one here is you can go into netacad.com and click careers, and you can get career advices, pathways, certifications, success stories, and things that are related to teaching you about resources that might be useful to you or ways to improve your job hunting related to Cisco. And then that takes us to the summary page. So we're done with Chapter 10. I will be activating the Chapter 10 exam soon on netacad.com and putting an announcement about that in Blackboard.